Hi everyone! In this video, we're going to explore the solution to the 2021 AMC 10B problem 21. A square piece of paper has a side length of 1. So, 1. And we're basically saying that as shown in the figure, we're folding it so that vertex C meets edge AD. So we're basically folding this point here to this point here, across this fold point right here. So what do we know about folding? When we fold one point to another point across some fold point, the distances, we actually discussed a very similar problem in the AMC 10-12 classes. So we discussed that if we fold something, these two segments will both be equal, because the distance between the C and the fold point is going to be equal to the distance of C prime and the fold point. Because continuing on the problem, we're given that C prime D is 1/3, so 1/3. This means that AC prime will be 2/3. Okay, so we want to find the perimeter of AEC. So let's mark our 90-degree angles on the square. We know all side lengths are going to be 1. So first of all, let's look at this condition that the two green segments are equal, because that's what we know about folding. So let's say this is x, right? Then if this is x, this will be 1 minus x, since sum of the distances between these two segments will have to be 1. From here, we can use Pythagorean theorem to get that 1/3 squared plus 1 minus x squared has to be equal to x squared. And then we can say this is going to be 1/9 plus x squared minus 2x plus 1 has to be equal to x squared. So from here, what we can do is we can cancel out x squared, and then that gives us 2x equals 10/9, or that x will be 5/9. And then from here, we substitute x into our equation. So we substitute x into our diagram. We got that this will be 5/9 here, and this will be 5/9 too. And this will be 4/9. So now, how do we relate that to the side lengths of AEC? So what we can see is that to find the perimeter of AEC, we need to somehow find the side lengths of ABC. And how can we find the side lengths of ABC? Well, we know one side length already, so now we just need to find 2 more. Well, we can easily find EC by Pythagorean theorem if we know AE. So really, we need to find AE. And is there any easy way we can do that? AE. So the thing is, this is 90 degrees. And when we have 90-degree angles and 2 angles opposite of it, they will be complementary. And having complementary angles and 90-degree angles makes us think of similar triangles. So this will, let's say this angle is A, and this will be 90 minus A, and this will be A, and this will be 90 minus, A, and then 90 minus A. And that means the triangles will be similar, because 2 angles are equal. Okay, so if we know that two angles are equal, we know they're similar, meaning that, and also you can notice that 1/3 is also just equal to 3/9. So we can see that the ratio of CD to, let's call this point F, CD to DF is 3:4. And that means it's 3/9, 4/9, 5/9. That should remind you of the 3, 4, 5 right triangle. And that means that AE will be 3/4 AC, because 3, 4, 5. So it means AE will be equal to 3/4, 2/3, which is going to be equal to 2/4, which is 1/2. So AE will be 1/2, right? From here, we can see AE will be 1/2. So now, what is the perimeter of AEC prime? Well, from here we can find the hypotenuse either by Pythagoras theorem, or we can just use the same 3, 4, 5 ratio to find that it will just be equal to 5/4 of 2/3. So 5/4 of 2/3 is just equal to 5/6. So 5/6. And then we just add up. 1/2 is 3/6. 4/3 is 5/6. So 3/6 plus 4/6 plus 5/6 is 12/6, which is equal to 2. And this is our answer is A. So basically, the key idea in this problem was fold segments are equal. We discussed this idea in the AMC 10-12 series classes. So for those of you who attended, you probably would know that the two segments will be equal. And then from there, we saw that 90-degree angles, we've got a bunch of similar triangles. Okay, so if we have a bunch of similar triangles, and that gives us Really good ratios because we know the 90-degree angle, which gives us similar triangles, and that allows us to calculate the silence of AEC and the perimeter. Really cool problem, and I think this is probably a bit easy for number 21. Thank you all for watching, and I hope to see you all in the next video.